Node.js or Node is an open source and cross-platform runtime environment for executing JavaScript code outside of a browser. Quite often we use Node to build backend services, also called APIs or application programming interfaces. These are the services that power our client applications, like a web app running inside of a web browser or a mobile app running on a mobile device. These client apps are simply what the user sees and interacts with. They're just the surface. They need to talk to some services sitting on the server or in the cloud to store data, send emails, or push notifications, kick off workflows, and so on. Node is ideal for building highly scalable, data-intensive, and real-time backend services that power our client applications. Now you might ask, but Mosh, there are other tools and frameworks out there for building backend services such as ASP.NET, Rails, Django, and so on. So what's so special about Node? Well, Node is easy to get started and can be used for prototyping and agile development. But it can also be used for building super fast and highly scalable services. It's used in production by large companies such as PayPal, Uber, Netflix, Walmart, and so on. In fact, at PayPal, they rebuilt one of their Java and Spring-based applications using Node, and they found that the Node application was built twice as fast with fewer people, in 33% fewer lines of code, and 40% fewer files. And more importantly, they doubled the number of requests served per second while decreasing the average response time by 35%. So Node is an excellent choice for building highly scalable services. Another reason for using Node is that in Node applications we use JavaScript. So if you're a front-end developer and know JavaScript, you can reuse your JavaScript skills and transition to a full-stack developer and get a better job with better pay. You don't have to learn a new programming language. Also, because you can use JavaScript both on the front end and on the back end, your source code will be cleaner and more consistent. So you will use the same naming conventions, the same tools, and the same best practices. And finally, another reason for using Node is that it has the largest ecosystem of open source libraries available to you. So for pretty much any features or building blocks you want to add to your application, there is some free open source library out there that you can use. So you don't have to build these building blocks from scratch, and instead you can focus on the core of your application. Next, we're going to look at the architecture of Node. So in the last video, you learned that Node is a runtime environment for executing JavaScript code. But what is a runtime environment really? Well, before Node, we used JavaScript only to build applications that run inside of a browser. So every browser out there has what we call a JavaScript engine that takes our JavaScript code and converts it to code that a computer can understand. For example, Microsoft Edge uses Chakra, Firefox uses SpiderMonkey, and Chrome uses V8. And it's because of these varieties of engines that sometimes JavaScript code can behave differently in one browser or another. Now, a browser provides a runtime environment for JavaScript code. For example, you probably know that in browsers, we have the window or the document object. These objects allow us to work with the environment in which our code is running. Now, up to 2009, the only way to execute JavaScript code was inside of a browser. In 2009, Ryan Dahl, the creator of Node, came up with a brilliant idea. He thought it would be great to execute JavaScript outside of a browser. So he took Google's V8 engine, which is the fastest JavaScript engine out there, and embedded it inside a C++ program and called that program Node. So similar to a browser, Node is a runtime environment for JavaScript code. It contains a JavaScript engine that can execute our JavaScript code. But it also has certain objects that provide an environment for our JavaScript code. But these objects are different from the environment objects we have in browsers. For example, we don't have the document object. Instead, we have other objects that give us more interesting capabilities. For example, we can work with the file system, listen for requests on a given port, and so on. We can't do stuff like that inside of a browser, right? So, in essence, Node is a program that includes the V8 JavaScript engine plus some additional modules that give us capabilities not available inside browsers. We can work with the file system or the network and so on. Both Chrome and Node share the same JavaScript engine, but they provide different runtime environments for JavaScript. Now, I've seen people comparing Node to C# or Ruby or some other programming languages, but these comparisons are fundamentally wrong because Node is not a programming language. It's like comparing a car with an apple. By the same token, Node should not be compared with frameworks such as ASP.NET or Rails or Django and so on. These are frameworks for building web applications. Node is not a framework. It's a runtime environment for executing JavaScript code. Next, we're going to look at how Node works. So earlier I mentioned that Node applications are highly scalable, and this is because of the non-blocking or asynchronous nature of Node. What do I mean by asynchronous? Let me give you a metaphor. Imagine you go to a restaurant. A waiter comes to your table, takes your order, and gives it to the kitchen. Then they move on to serve another table while the chef is preparing your meal. So the same person can serve many different tables. They don't have to wait for the chef to cook one meal before they serve another table. This is what we call non-blocking or asynchronous architecture. And this is how Node applications work. The waiter is like a thread allocated to handle a request. So a single thread is used to handle multiple requests. In contrast to non-blocking or asynchronous architecture, we have blocking or synchronous architecture. Let's see how that works. So back to our restaurant example, imagine you go to another restaurant, and in this restaurant, a waiter is allocated to you. They take your order and give it to the kitchen. Now they're sitting in the kitchen waiting for the chef to prepare your meal. At this time, they're not doing anything else. They're just waiting. They're not going to take an order from another table until your meal is ready. This is what we call blocking or synchronous architecture. And that's how applications built with frameworks like ASP.NET or Rails work out of the box. So when we receive a request on the server, a thread is allocated to handle that request. As part of handling that request, it is likely that we're going to query a database. And as you know, sometimes it may take a little while until the result is ready. When the database is executing the query, that thread is sitting there waiting. It can't be used to serve another client. So we need a new thread to serve another client. Now imagine what would happen if we have a large number of concurrent clients. At some point, we're going to run out of threads to serve these clients. So new clients have to wait until free threads are available, or if we don't want them to wait, we need to add more hardware. So with this kind of architecture, we are not utilizing our resources efficiently. This is the problem with blocking or synchronous architecture, and as I explained, that's how applications built with frameworks like ASP.NET work by default. Of course, in ASP.NET, it is possible to use asynchronous architecture, but you will have to do extra work for that. In contrast, Node applications are asynchronous by default, so you don't have to do anything extra. In Node, we have a single thread to handle all requests. When a request arrives, that single thread is used to handle that request. If we need to query a database, our thread doesn't have to wait for the database to return the data. While the database is executing our query, that thread will be used to serve another client. When the database prepares the result, it puts a message in what we call an event queue. Node is continuously monitoring this queue in the background. When it finds an event in this queue, it will take it out and process it. This kind of architecture makes Node ideal for building applications that include a lot of disk or network access.